morning and good afternoon to everybody. I don't know if you are listening to me, if you can hear me and see me.
Yes, perfect.
Okay, thank you. Okay, I think we can start with the next session of the conference. I would like to share my screen. Please just tell me if you are seeing my screen.
Yes, perfect.
Okay, thank you. Thank you. Okay, good morning and good afternoon to everybody. And let me first present myself. My name is Roberto Guardani. I'm a chemical engineer and I'm a professor at the University of São Paulo, Department of Chemical Engineering at the Engineering School. So the topic of our panel is on air quality. And of course, this has a lot to do with megacities. And following our discussion, I will just present our participants. We have four participants taking part in this discussion. Professor Maria de Fátima Andrade from the University of São Paulo too, and from the meteorology area, let's say, and modeling. Mr. Vital Ribeiro from the Center for Health Surveillance, Department of Public Health of São Paulo State Government in São Paulo State. And we have two specialists from CETESP, which is our environmental agency of the state of São Paulo. Dr. Rui Abrantes, who is much involved with vehicular emissions, and Mr. Claudio Alonso, who has a large experience in air quality. Let me just say something about the São Paulo area, the São Paulo metropolitan area, how it's called. As you know, São Paulo is located in southeast of the Brazilian country, and it's a huge city, as you can see in these two photos here. It's a kind of concrete forest, typical concrete forest, and the city itself has some characteristics which are very typical, good examples of megacities. So São Paulo state itself is the most industrialized state in Brazil, and the metropolitan area of São Paulo covers an area of about 8,000 square kilometers. It's located at about 50 to 60 kilometers from seaside, but at an altitude of about 700 to 800 meters, and among just between two mountain chains. So you have a specific weather condition in São Paulo. The whole region, the metropolitan area, involves about 39 cities and a estimated total of 22 million inhabitants. So it's really a huge metropolitan center. Alone in São Paulo, we have circa 6 to 7 million vehicles circulating, with some specific characteristics, like a large part of those cars are fueled by a mixture. It's a gasoline, but containing about 25% ethanol in it. And also you have the flex fuel cars, which can run with either gasoline, pure gasoline, or pure ethanol, or any mixture among both. And about a large amount, about 500,000 diesel vehicles. Diesel vehicles are mainly service vehicles, like small trucks or large trucks or in buses. So normal personal vehicles are not diesel fuel. In terms of emission sources in São Paulo, as typical of most megacities in the world, most of the pollutants are emitted by vehicles. You have this in this plot here about 74, let's say, for 35% of the total pollutant are from other sources, but 75% are caused by light vehicles, personal vehicles. And also you see that for hydrocarbons, it's a large amount of so almost 2/3 of the total are represented by hydrocarbons. Then you have other main pollutants. These are the most typical ones in São Paulo as primary pollutants. And you have, let me just call your attention for the particulate matter 10 and 2.5 micron, which are controlled pollutants, which have more distributed sources like resuspension and secondary aerosols, mainly for MP 2.5. So this is the situation in terms of air quality in São Paulo, which is, as I said, is representative of many other mega cities in the world. So I think that our discussion will have to compare with other mega cities in other regions of the world. I just show you here a map of the region. It's a very simple map comprising all 39 cities and the network of monitoring points for air quality monitoring points, which are operated by the environmental agency. The name for it is SDEWES in São Paulo. So we have about 30 automatic monitoring stations that generate continuously data on the air quality. It's our source of information on air quality in São Paulo, and the primary source for all measures that are taken by the environmental authorities in the São Paulo area. And just talking about, just to finish my short presentation, just to mention some studies we carry out in connection with the environmental agencies, SDEWES, and the University of São Paulo. This is the reason why I am here coordinating this panel, is because my involvement is related to statistical analysis, statistical learning techniques applied to the huge amount of primary data that the network of monitoring stations generate. So we work on optimization of the monitoring network. We work on developing and fitting predictive models for the main pollutants, which are, in the case of São Paulo, I would mention ozone and particulate matter, which are the most problematic ones, and also some techniques for fault detection, so sensor detection for detecting problems and operating problems in the network itself. So these are studies that are carried out in cooperation between the university and SDEWES. So with this, I would just like to finish my presentation and pass over to the next participants. I first of all would like to thank very much everybody, every 4 participants who are taking part in this presentation. And I would like to pass the presentation over. I don't know if Mr. Rui is there. Hello, Rui. Good morning and good morning to you. Good afternoon, everybody. Rui works a lot, is dealing with vehicles emissions. So as I showed in the plot, São Paulo air quality is very much affected by vehicular emissions of pollutants. So thank you very much, Rui, for your participation. Please.
Thank you, Roberto. Can you see my presentation?
Not yet. We are seeing you.
Not yet. Okay, let me try again. Just a minute, please.
Yeah. Yes.
And now,
yes.
Okay. Thank you very much. Thank you for the event organization by the invitation. My name is Joide Abrantes. I'm working at SDEWES for 29 years in the type approval department of vehicles. I will talk about the Brazilian Vehicular Emission Control Program. In Brazil, its name is PROCONV for road vehicles and the non-road machines. PROCONV started in 1986, and it has reduced the pollutant emission targets and noise since then. Today, PROCONV is one of the most severe emission control programs in the world. Currently, we are in the phase, in the 70th phase of the for light duty vehicles that started in 2022. In this phase, we focus mainly in reducing strongly the evaporative emissions due to the ozone problems in big cities in Brazil. We introduced the limit of a half gram in 48 evaporative tests. 48 hours of evaporative tests. What rises the canister size, and the fuel tank is less permeating. It reduces the evaporative emission, including when the vehicle is parked. We are the 30th country in the world to introduce the RVR system that collects the evaporative emissions during the vehicle fueling. We started to collect data from real drive emissions. We are collecting nowadays CO, NOx, the total hydrocarbons. And the emission of particulate filter must be considered in the type approval process. In 2025, we will start the phase L8 for light duty vehicles, where we will focus mainly the reduction of the tailpipe emission up to 2031. We are introducing a new concept, the corporative emission, what permits a small amount of the previous phase vehicles to be sold that must be compensated by a very low emissions vehicles, including zero emission vehicles. We are controlling in this phase the real drive emission, and the emission of the ammonia will be the limit will be 10 milligrams per kilometer to control the ammonia slip from the SCR systems. For the heavy duty vehicles, we are in the phase P8. We started this year for new models, in next years for all models. The emission of DPF must be considered. We have a more severe OBD system with severe torque reduction, and at least one auxiliary emission strategy must be demonstrated to the type approval authority. In this table, we can see the emission durability required. That will be very important for us because during the in-service conformity program, we can confirm if the trucks and buses will really attend these requirements. In Brazil, we are measuring CO, NOx, total hydrocarbons. We are not measuring particulate matter and particle number. The CO2 must be reported also. The GEGR must work up to 1,000 meters above the sea level. And in Brazil, we have idle control. Our automatic engine shut off after 5 minutes working in idle conditions. Non-road machines, we started in 2015. It is applied in all earth moving machines and agricultural machines. This phase is equivalent to the American phase Tier 3. For motorcycles, we are in the phase, in the 50th phase. The program started in 2003. Nowadays, we start next year. We will start the the phase M5 for new models, and 2025 for all 2025 for all models. We have a special emission limit for aldehydes, equal to 20 milligrams per kilometer. We measure just formaldehyde and acetaldehyde due to the presence of ethanol in the fuel. Particulate matter control for motorcycles with the direct injection will be 4.5 milligrams per kilometer. We will start also the OBD concept for motorcycles, and we started the evaporative tests in 2 hours in 2 phases, cold and hot phase. As a conclusion, with so low emission standards, the surveillance is more and more necessary to assure the effectiveness of these programs. We intended to focus in the in-service conformity program to turn the phase P8 effective and improve the air quality in Brazilian big cities. And we intended to improve our surveillance program to avoid the AdBlue tampering in the field. Thank you for your attention.
Thank you, Rui. We'll come back to you to questions to discuss some of the points you introduced in the next minute. So now, by now, I'm going to the next participant. I don't know, Claudio, would you like to make to prepare your presentation, to share your screen? Claudio?
Okay. I didn't push the right button. Okay, I can tell you something about São Paulo air quality as we planned, and I will share my screen.
Not yet. We are seeing you now, not your screen.
And now, okay?
Yes, okay. Just can you change the presentation mode? Yes.
Bye, caramba. Oh, it's okay. First of all, I have to, on behalf of SDEWES, to thank to the organizer for the invitation to present in this section. I live in the US 30 years ago, and I spoke a very fluent English. Today, I speak good broken English, then excuse me for that. Let's start. Just remember for the date, the London episode in 1952, with the reduction in visibility estimate of 2,000 deaths, and result as high levels of particulate and sulfur dioxide. It was a good warning to the world to start in air quality protection activities. For that, in mid of 60, SDEWES started measuring air quality with a manual network in São Paulo metropolitan area, basically measuring particulate and sulfur dioxide. Then in 1980,
Claudio, just a moment. We are not seeing your screen. The slides.
No.
We are only seeing your first slide and not in presentation mode.
I was talking about the episode with reduction of visibility, estimate of 4,000 deaths, and was a warning to the world that to start an air quality protection. Obviously, before that, several studies were done about that, but the London episode was a warning very strong. Air pollution in São Paulo starts, the measurement starts in the mids of 60 with a manual network measuring basically particulate matter and sulfur dioxide. In the early 80s, we start with an automatic network that allow us to to measure other pollutants and increase the number of stations in SPMA, in the metropolitan area, and also in the countryside. This characteristic of São Paulo, Roberto has told you, 645 cities. This is a number important that I will use again. The monitoring air quality is made in 42 cities out of the 42 cities out of the 645 cities that we have in the state. We have 85 stations, but we attend about 28 million people out of 47 million people that lives in São Paulo. This means that our network covers about 60% of the population, attended about 60% of the population of the state. Obviously, the other cities, most of them has low population, low vehicles, low traffic, then in general low industries, then no emission, no pollution. This is a picture of our network. The first one is the outside station. The second one is the inside station. This is the central station that permits to share with the people on time our data. There's a manual monitoring station. Typically, it's a high volume with PM10 head. And this is the laboratory where we make our measurements. Okay, now let's start again. How is measured the air quality in São Paulo? I present the air quality network in such a way that is important to us. The kind of pollutants we measure according to the number of stations we have. Then we have meteorology in 50 stations, measuring temperature, pressure, wind direction, wind speed, radiation, relative humidity. These are parameters to help us to understand the pollution. We measure in 3 places in metropolitan area, total reduced sulfur that smells bad as a consequence of roads and rivers we have here. The volatile organic carbons is measured in 7 stations, basically to measure benzene for health questions, and all the aromatics and aldehydes to understand the formation of ozone, as the VOCs are parameters that are participate in the photochemical reaction. Something more, we have 19 CO stations, in my opinion, too much stations, to measure carbon monoxide, and 23, in my opinion, a lot of stations to measure SO2. Now we'll go to the hardcore of the network, where we measure NO, NO2, NOx for health reason and to understand the formation of ozone. Let's see, 3, 7, 19, 23, 45 is increasing the number, and increases something more when it started the measurements of ozone with 53 places measuring this parameter. Obviously, particles are the most important, the most concern we have, and we have 113 monitoring equipments. Obviously, PM10 we measure in 60 places, PM2.5 in 35 place smoking relatively to content of carbon. We measure in 9 places. TSP, an old parameter, basically measure the total particle of the city. Okay, and PM1. PM1 is a very new concern we have, and probably is the best study that we are doing now, because the first study we have done is about the same as occurs in other part of the world. 80% of the PM 2.5 is PM1. This means that the PM 2.5 have to be controlled to control the PM1. As because they are very fine particles that penetrate in the lungs. The SO2 behavior, I told you that we have a lot of stations. Why? I just give you an example. We have a standard of 60 micrograms per cubic meter, 24-hour average. This is a good example of what happened in the behavior of SO2. Capoava, a place here in São Paulo metropolitan area, in 1982, was the worst place for SO2 in metropolitan area. The concentrations at that time were above of 600 micrograms per cubic meter in not only one measurement, a lot of days with this concentration. Today, 2021, as a matter of fact, 22, Capoava is still the worst place, but the concentration now is 12 micrograms per cubic meter. It's a good reduction if you imagine all the city, and as a matter of fact, in the state, with some exception. The control was reduction of reducing the sulfur content in all kinds of fuels. This means what? That some industry changed the oil, the burning oil, to burn gas. Is a kind of a reduction of sulfur emission. As a matter of fact, in industrial areas, 2 or 3 areas here in São Paulo state, very industrialized areas, Cubatão is an example. We have once in a while concentrations over the standard. The standard is 60 today, but the World Health Organization in 2021 published a guideline that for SO2 24-hour average is 24 is 40 micrograms per cubic meter. This means that even with more stringent value, we are very safe about the air in terms of SO2. The CO behavior is about the same. Standards 9 ppm for 8 hours. In 80s, more than 30 days exceeding standard we could observe in the city. And it was not just exceeding the standard, but also values are 30 to 35 ppm was observed. Today, since 2008, no exceeding was observed, with maximum 8-hour average of 4 ppm. The controls obviously was the better quality of fuels, electronic devices, and catalytic devices in cars. Let's see. Excuse me. The WHO, World Health Organization, to 24-hour average point to 3.6 ppm. We are safe on that because 8 hours maximum was 40, then for 24 hours it's okay, no problem. This is the hell. The hell is called ozone. It's a very unpolite pollutant that goes up and down, and we don't know why this happened. Why? We measure NO2, we measure ozone, we measure organic volatiles, and probably is the variation of the tropical sunlight. I cannot understand why this is happening in such a kind of variation. And you have to understand that these are number of days. These are number of days with exceedance violation of standards, the 140 micrograms per cubic meter. Can you imagine if you made the same graphics with the WHO recommendation of 100 micrograms per cubic meter? The number of exceedance obviously will be much more. We keep studying the precursors of ozone, and someday we understand what is happening here in São Paulo. The control obviously is the NOx in the trucks using urea as to abate the NOx formation, and the VOCs control also. This is one example what happened with PM10 in metropolitan area. This is a Brazilian language. All these squares, all this box shows what the control attitude of control were taken. In the beginning was very high. Before 1985 was higher than that. The 79 in this starts the control of PM in industrial facilities, and now is going down, and we reach to 20. Será que dá para ver isso aqui? Bom, reach 25, 27 is stable since 2015, 2016. The standard used to be 40 micrograms, 40 micrograms per cubic meter. The new recommendation of World Health Organization is 15. Then this is changed a little bit, but the number of days, here is not the number of days, here is the concentration. We reached the concentration of about 30 micrograms per cubic meter, and you can imagine that is an average of São Paulo metropolitan area. This means that there are some stations higher than that and some stations lower than that. But we know that the variation here is not so good, so big. Yes, some stations are higher and some stations are lower, but not too much. I don't know. In a big city, this kind of standard could be attained, but let's see what will happen. What happened comparing São Paulo with some city? Here we take 2 PM to 2.5 and some cities. In São Paulo, as you can see, is about the same in several stations. 14, 13, 11 is about the same. New York, not so different. 9, Lisbon 9, Madrid 9, Brussels 9, and so. And Milan in Italy, they eat too much pasta and have PM 2.5 is higher than other parts of the that we find. The interesting to see is that observing the behavior along the last 3-4 years is about the same all the time. Okay, it's about the same. No significant difference from the previous year with the big pandemic restriction of cars. In terms of annual measurement, the annual measurements of all the cities It doesn't matter if it was a reduction in traffic or not. In São Paulo, it was very high, the reduction of traffic. Even so, the PM 2.5 doesn't change too much as we expected. On the other hand, São Paulo has a standard of 20 micrograms per cubic meter, and the World Health Organization indicates that has a new guideline for 5 micrograms per cubic meter. I don't think that I will be alive to see that. I think is almost important in a big city.
Claudio, please, if you can conclude in 1 or 2 minutes, please.
Is the last one. Observation in pandemic. 2.5 micrograms per cubic meter, for instance. In Mexico City was a reduction of about 16%. In London, about 10%. In São Paulo, also a reduction. But in ozone, reduction in all parameters, but in ozone went higher. In London, 33% more, and in São Paulo, about that also. What does it mean? That the reduction, big reduction that we have in traffic circulation was important to reduction particles and CO and so, but was not important to reduction of the reduction of ozone. There are some theories about that, but we have to stop here and I have to thank you for your attention. And okay, thank you.
Thank you, Claudio. Let's go to the next participant. I invite you, Dr. Vital Ribeiro, please, if you can start your presentation.
Thank you, Roberto. Hello, everyone. Good morning, good afternoon, good evening. Thank you for this opportunity. I'm replacing my colleague, Sergio, that has a last-minute problem. So I will share my screen. Let's see. Can you see? Can you see my screen?
Not yet.
Okay. It's okay now?
Just a moment. Yes, we see it perfectly.
Thank you. So I will be, my name is Vital Ribeiro. I work on the Environmental Health Department of São Paulo State's Secretary of Health. I will be talking about air pollution from the perspective of public environmental health. And we don't use much this expression, public environmental health in Brazil, but I really recommend we start thinking in this framework. And here. I'm using some slides from colleagues, in this case from the Planetary Health Alliance, to just start by showing how the humanity has been doing a great job on reduction mortality and life expectancy, growing life expectancy. So there are lots of achievements on public health due to the development of technology and many other aspects that contribute. But we also see the acceleration of consumption of natural resources, and all these factors contribute to environmental depletion, pollution, and resource scarcity. So we see the growing of plastic use on everything, the exponential use of energy, water. So this is causing a lot of transformation in the whole Earth. And we see also the impact on biodiversity, on marine life, and acidification. So this is just an introduction about the environmental global crisis that we are facing to prepare for the climate crisis approach that I think it's the most important challenge for health in the world, and we are already facing this. And I'm talking about climate change because there is a very close relation with air pollution. So the base of climate change is fossil fuel use, burning, and this is also the main cause of air pollution. Sorry for being so obvious, but it's the fact. And we see that climate change also makes worse all the other health problems that are traditional. So we have the emerging disease, the traditional disease, the infectious disease, the degenerative disease. All these categories are getting worse by climate change effects. So this is the most aggressive challenge that we have to face, and I think health is one of the three basic approach for the climate change discussion. Is health and economics and social issues. And I believe that we don't discuss enough health implications of climate change. So there is an effort from international organizations like WHO, and there is a great work from the Climate and Health Alliance, Global Climate and Health Alliance, that are doing this job too, and the Planetary Health also. I want to call your attention about the air pollution that causes about 4.2 million deaths per year. This is additional deaths caused by air pollution and environmental air pollution, ambient air pollution, not excluding the indoor air pollution that is also a huge problem connected with social issues. So we used to think about air pollution just about respiratory and lung disease, but some of the most important disease, the most costly disease for the public health systems are caused by air pollution, and we don't see like this. We are talking about stroke, heart disease, hypertension, and many other that are, including cancer. And so we have this kind of lack of perception of how serious is air pollution for the public health. And the connection with the air pollution and climate change, as I said before, it's very clear. So we have this different approach from short-term, long-term, local and global, but everything is connected with basically transport, industry, energy production. So we see how there is the impact in that. This is material from WHO, and how air pollution impacts in that, and how connected it is to climate change. another aspect important to be considered when we are talking about public health is the inequities and how unfair is this process. We see above the words emission per country or per region, and the mortality below the mortality. So we see how much the low-income countries will suffer the consequence. And this means that this population don't have access to healthcare, don't have options, don't have good opportunities to have access to safe water or food. All this is connected with climate change and air pollution too, including in Latin America, we have the most unequal region in the world. So this makes the challenge much harder for Latin American countries. I just want to conclude my presentation by calling attention about how to deal with air pollution considering public health. I see many studies discussing air quality based on the WHO parameters and standards, but what we see from a few years from now is the growing discussion about vulnerability. So there is a whole field to be explored on how different people feel the impact of air pollution. And based on this, we have a strong mobilization on health organizations to promote the discussion about how to create solutions for climate change and air pollution. Particularly here is the health argument for climate action. It's a document from WHO that it was presented on COP26. I call attention for the item 5 and 6, decarbonization of the whole economy implies in clean energy, clean mobility, public transport, and controlling the air pollution. I just want to conclude with inviting you to reflect about how different people suffer the consequences of air pollution. We started some studies a few years ago by measuring PM 2.5 with a mobile device. And this shows that if you live near a high traffic avenue, if you live in a poor house without glasses in the windows, if you work on the streets, driving a bus, or if you are a waste picker that are on the streets looking for something to survive, you are exposed to a much higher level of air pollution. So in these kinds, the ozone level, the PM 2.5, could reach much higher levels than the average measured by SDEWES. I'm really a fan of Claudio Alonso. I know his work. I know the work of CETESB and Rui Abranches, but I think there is a complementary approach by discussing how some groups of people, some small regions in the big cities are exposed to air pollution, and we need to discuss these too. That's what I have to say now. Thank you very much.
Thank you, Vital, for your presentation. Introduction. I now invite Professor Andrade from the University of São Paulo for her presentation. Please, Professor Andrade. I don't know if you can hear me. Oh, hi.
Yes. So, thank you. Thank you.
Thank you very much. Yes, please. Sorry.
I will first share my screen to see if it's possible to see my screen.
Yes.
Is it okay?
Yes, yes, it's okay.
Thank you. Well, first I'd like to thank Professor Guardani for the invitation, and I will present something that we have started now in São Paulo. It's a project with funding from FAPESP, that is our agency for funding science, and we start measuring some greenhouse gases in São Paulo, and I will present some of our results that we have until now. Well, the summary of my presentations, I will start trying to do a motivation for the impact of our the impact of having the emissions inventory for the greenhouse gases and some data, and two examples, that is during the COVID and during the forest fires here in Brazil in 2020, to show how they impact the concentrations. Well, we have a motivation for starting these measurements of the greenhouse gases in the urban areas. Usually the emissions, the inventory that we have, they are based on these bottom-up accounting methods. Usually we don't have measurements. The measurements we have are more concentrated in remote places like Hawaii and the Pacific, and we see the increase or the variation in the concentrations in the greenhouse gas according to the time only for these remote places. But since I think 10 years or something or less, some cities starting doing measurements inside the urban areas, like Los Angeles and also Paris, and we have also data from Pennsylvania and for Houston. And the motivations is that to improve the data, to know how the cities are contributing to the total emissions of the greenhouse gases, and also to have more data to compare with the emissions inventory. Then this is the motivation to have all the measurements performed in urban areas. When this is a map of the emissions, the total emissions of CO2 equivalent. This is from this SEG platform. Let me see if I have here a pointer. This is from this site, from SEG platform for the emissions of greenhouse gases. And we see here the sectors. Depending on where we are, we have the emissions related to livestock or to vegetation, burning of forests. But when we go to the cities, we have the emissions of the CO2 equivalent, the total CO2, come from the energy sector. And this, if I am going to present more data for São Paulo, and we are going to see that for our cities, most related to the transport sector. Guardani has already presented information about São Paulo city and the metropolitan area, but when we go to the emissions inventory for CO2 in São Paulo, in the city of São Paulo, this shows that the energy sector is responsible for most of the emissions. We have only here a small part of the emissions related to the waste, but the stationary energy is responsible for 30%, and we have 6% related to the transport sector. And then going to the description of our project, we start with 5 stations. These 5 stations, they are distributed in different parts of the city. The idea, our project is has this name, Metroclima Project, and it's a collaboration among many institutions. And in the project, we have the measurements and also we have the modeling. We have people working with surface data, but flux measurement, I'm showing some examples, satellite data, and the atmospheric modeling and inverse modeling. It's a big group, and we have many students, PhD and master students working with this data. And we have 5 sites. One site is in Pico do Jaraguá, that's a high place in the city. And the idea is to be like a background. I'm showing some results related to this. We are together in the air quality station from CETESB. You see here is the air quality station, and we put our instrumentation here. This is a Picarro instrument like this one that is in our campus, inside the main campus of the university. We put another equipment in a tall building that is it's a cancer institute in São Paulo, and it's a building higher than 100 meters, and then we have in the top of the building equipments. Also in the middle of the city with low impact of vegetation in the east zone of the city, and also in a park and in the south of the city, where we have also other kind of measurements, and I'm showing more data for this park. Because when we have the configuration of the São Paulo city, it's nice to show that we are not so far from the coast, but we are in a hill that's more than 700 meters above the sea level, and this makes an impact related to the sea breeze. And also here in the northwest part of the city, we have this high place that is the Pico do Jaraguá. In this area, we have some relatively high mountains, hills here, and then this makes a circulation, a specific circulation, that we have the sea breeze and mountain circulation here over the metropolitan area. This is only to show more with more details and with this idea of the circulation, the 5 stations that we have. I can also discuss more if you need, but at each place we have the equipment, and also we have the gas for calibration. The calibration is this tank is from NOAA, because for the greenhouse gas we expect to have data that can be compared with other places. Then we are following the protocols from the WMO. And one of these stations in the Parque Cientec, in the south of the city, in this place here, we put our also system for measuring flux in a radar tower. We have also the ceilometer to measure the boundary layer, having this kind of information. The boundary layer is an important parameter, and we usually have only the sounding profile coming from the airport, and then it's important to have this hourly behavior of the boundary layer that we are measuring. Also, we have in the campus this equipment for measuring the total column of the CO2 and methane. We are measuring both also. The column to compare with satellite data. And here, showing some results, we started the measurements before 2009, but since 2009, we have the measurements with the calibration system according to what is expected from the WMO and other protocols for measuring greenhouse gas. Then we are only consider data from 2019. And when we compare different stations, we see that the behavior is different, mainly during the day. And this is very interesting because it's related to the presence of the vegetation. I have here separate for each station, but also one picture showing the comparison among these 4 stations here. And we see that the stations that are more in the center of the city, more impacted by emissions from the mobile source, like from the vehicular emissions, we have the highest concentrations. But during the night, the behavior is different. We have to observe that the stations that are higher, like the Jaguaré and the CESP, they have different behavior during the night. And the stations that have more vegetation also, they present different behavior during the middle of the day due to the interaction between the vegetation, the photosynthesis process of the vegetation. It's usually we were very used to describe the behavior of the pollutants or try to understand the behavior of the pollutants, and it's difficult to consider the biogenic emissions, even for the ozone production, as Claudio was showing. But also now we need to have the interaction of the vegetation to explain the behavior also of the CO2 that's very impacted by the surroundings, if you are more in an urban or more in a vegetated area. Concerning the use of Pico do Jaraguá as a background station, what was done, it is a master project of a student. He calculated some background data considering a criteria that is, he took data that has a small variability, then within an hour period, a small hour-to-hour variability, and the persistence of the first 2 conditions for several hours. And then here we have this in red colors, these dots, would be the background data. And this blue line is a smooth curve of this background data from 2019 to 2000, to the end of 2021 for the Pico do Jaraguá station. Then we are considering that this blue line is our background of CO2 concentrations in the city. And when comparing the measured concentrations and the background concentrations, we have this difference between the two, and we have this increase with time. And when we calculate the increase, but it's only 3 years, it's very, it's not a so statistical date, but it's for these 3 years, we observe this increase in these 3 years of 2.5 ppm per year for the concentrations measured, and for the background, 2.8 ppm per year. And when we compare, this is the data from NOAA, comparing for the same years from 2019 to 2021, we have this 2.5 ppm per year that is consistent with our data. And also the excess from the average measured from the average background is 4 ppm, the excess of CO2. Looking at this monthly average, it's interesting to see that here, when we had the lockdown, it was almost 1 month that we have a real lockdown. It was from end of March to April 2020. It's interesting to see that the measured concentration was very close to the background concentration that was calculated with that statistical filter, showing some consistency with the calculation and with the data. Another example that I'd like to show is this Amazonian and Pantanal forest wildfires that occurred in September 2020. And these pictures, I know it's a little bit confusing, but this mix the air quality stations from SDEWES, also our data from CO2 measurements. This is for September 2020, and I will start first showing here the CO2 data. This CO2 from 3 stations, IAG, Unicid, and Jaraguá stations. That's these lines here. This blue total here is when we had some rain, And before this rain, this cold front, we had this northwest circulation, wind coming from inside the country. And it was possible to see this high increase in the concentrations of CO2. Also, this plot here in the middle is the concentrations of PM 2.5 at these different stations that are here, the SDEWES stations. And at the same time, when we had this increase in CO2, we have also this increase in PM 2.5 at most of the stations. But how to know that they come from biomass burning? We are also measuring the delta 13 of carbon in CO2 in one station. In IAG station, there is also isotope measurements of delta 13, and it can indicate if it's biomass burning or if it's fossil fuel according to this ratio of delta 13. And that this, when we had these high concentrations of PM 2.5 in these events, and also we have this high concentration of CO2, we can see that the ratio, the delta 13, is more related to the biomass burning. Then we are trying to put all this data together to have this information, to know if we are having contributions from these events of burning, of biomass burning or not. Because sometimes we had the biomass burning, but we don't have the same effect or the same variation in concentrations observed in our city. Then it's interesting to see this data, and what we are expecting is to have more information to be possible to evaluate the total amount. This information is quite important, this delta 13, but there is a problem for us in São Paulo or in Brazil, because as we use ethanol as a fuel, it has also the same signature of the biomass burn inside the fuel because of the presence of ethanol that is from sugarcane. Then this is also brings more complexity for our study. Then this is what I like to present to introduce to everybody that we are starting measurement of these greenhouse gases. And we have a summary, some points, but from this point, what I think it's important is that we need more stations. We need to find some place that we can really think there's a background station. We also need to develop the modeling to make the constraint between the emissions and the concentrations. That is this inverse modeling that is not so easy to perform. That's something that we are trying to implement also. And with this, I'd like to thank and invite people to visit. We have this website, and the data is being publicized there in these websites, and we try to keep this data and available to be also checked and analyzed by other collaborators. Thank you. Thank you for the attention.
Thank you, Professor Andrade. And we now, after this short presentation from the 4 participants, we enter the discussion section of our panel. And I don't know if there are questions from the audience, but I myself have one first comment on what has been presented by the 4 participants, and it's clear for that there's a big interconnection, interference among air quality, climate change, and human health in the case. So you cannot treat these processes or this aspect separately. So you need to actuate in a coordinated and an integrated approach. That's one general comment I would like to know, to make, to state based on what has been presented here. And but I have some comments and some questions, additional questions too. Let me just make one first question from myself, then we can open for the audience. Some concerning what has been said about air quality in cities like São Paulo, and as been shown, the main sources of air pollution that are affecting air quality in cities like São Paulo are generated by vehicles. And what is the tendency in terms of standards for vehicles or restrictions for vehicles? You know that, for instance, in European countries, in European cities, in many big European cities, you cannot enter or circulate with a car that does not attend some emission restrictions. So you have specific regulations for that. And of course, the tendency worldwide is to go to electric cars, for instance, and in Brazil, in São Paulo specifically, we have a large percentage of biofueled cars. As I mentioned in the beginning, you have these flex fuel cars which can run with pure ethanol or pure gasoline. So, and normally what is used is a mixture among both. And the question is, what is the tendency in terms of how do you believe is the tendency in terms of, first, the car standards in terms of emissions, since emissions are getting progressively more restrictive, and second, what can be done in terms of urban planning, since you have an importance, growing importance of public transportation in big cities like São Paulo and of course many others around the world. I don't know if anybody can comment on that. If I can ask any one of you to make a comment.
I'd like to comment it. If you allow me share again my screen.
Yeah, please.
Just a minute. This graph compares the American standard tier 3 and the program for light duty vehicles. So here we have the American standards. In 2025, they intended to reach the emission limit of 20 milligrams per kilometer of non-methane organic compounds plus NOx. And Brazilian standards intended to reach this minimum emission level in 2031. The emission limit will be 30 milligrams per kilometer. So I think for light duty vehicles, we tend to have a reduction in the pollutants emission in short time, more or less 5 years or 6 years. Regarding to the heavy duty vehicles, the changing rate is slower because these vehicles are more expensive and they are able to resist much more time working. So maybe for heavy duty vehicles, this changing could be lower and the benefits to be observed in the atmosphere can be a little bit delayed.
Okay, thank you, Rui. Does anybody want to make any comment on what Dr. Rui has mentioned and I?
Roberto,
Yes.
yes, I think that there are different strategies. We should consider things that depends on national policies, like controlling vehicles manufacture and other and energy. For example, energy is something that it's the federal government that took the main decisions on our energy metrics and transportation too in many aspects. But we also should focus on what could be done at state level or local level. I think there is many approach to add some gains on air quality that could be thinking locally. I was thinking about the PM 2.5 and see how cleaning the streets is used in many developed countries to reduce the amount of particulate matter or washing public places, reduction of exposed materials. So there is many possibilities for facing this challenge. I also call attention when we are talking about energy, the option of using diesel generators that are used for many hospitals, for example, in central areas of São Paulo, should be considered maybe changing for options, cleaner options like photovoltaic energy in a short term. I think it's very promising investments. Also talking about energy, there are projects about burning waste to produce energy. I don't think it matches the targets on air pollution control. Even if you have high level technology, and we are afraid that probably we will not be using the state of art of incineration because it's really expensive. So if we continue to invest in energy from waste, it could be a risk for reaching targets on air quality, particularly because these plants are planned to be built on very populated areas, very concentrated areas. So I just want to call attention about the opportunities to an integrated approach for air quality, considering many sources, including, we used to say that the majority of pollution is vehicles, but I believe that when we are looking for a specific neighborhood or place, we should consider also industries or small industries that sometimes are not seen by the environmental agencies because it's too small. So there is a lot of things happening in the city, and we should invest in all options together to take advantage of this synergic approach. And this could reflect also much more in health condition of the population, because it affects they are breathing at this place, not the average air. That's something that I would like to raise here.
Okay, thank you, Dr. Rui. Dr. Vital, thank you. And just a comment, in many other countries, diesel cars, for instance, they need to have particulate matter filter. So and also a system to react with NOx in order to produce nitrogen. So you have those the blue urea solutions, for instance, which is obligatory. And in countries like ours, like in Brazil, this comes gradually. Not all vehicles use it, and the hope is that this grows in the near future. But I would like to ask about the tendencies in terms of public transportation, for instance, and individual transportations. In the world, the market for electric vehicles is growing. The infrastructure for that is growing, and this is something that will actually will have a positive effect in terms of compliance of the cities, in terms of greenhouse gases emissions, like has been mentioned here. The cities, the big cities, especially big cities like São Paulo, need to be compliant with global tendencies, global objectives of decreasing greenhouse gases emissions, and electric vehicles will contribute to that, and of course contribute to air quality. Of course, this has a cost, but this is what has been the tendency worldwide. I don't know about the situation in São Paulo, but this is what will be the tendency in the next 10 years, right? I don't know if anybody wants to make any comment. If there is any question from the audience,
Roberto, we are rising rains here.
Oh, really? I couldn't see you. Just now.
You see, that is it is very nice because you can rise your rain with this.
Oh yes, I couldn't see your hands. Okay, now you see.
Me and the Claudio.
I don't know who was first, you or Claudio.
It doesn't matter. I don't know. Claudio, you are mute.
Yes, Claudio, you're mute. Please turn your...
Ladies first, ladies first.
Oh, thank you. No, it's only to complement what Vital was saying about local measures. I was thinking about this, and also you said about the buses and this electrification. Sometimes I think that some simple, or not so simple, I don't know if it's simple, but like in these bus corridors, we have these bus corridors and very close to the people who are waiting for the buses. And we know that the buses emit a lot of particles, mainly small particles, nanoparticles. And sometimes the planning could be like implementing the electrification of these buses in the corridors. Then if you think that, yes, the people stay there for short period usually, but they stay most of the population every day for maybe half an hour every day there in these bus corridors. And if we usually when you are in the buses, you feel the smell of the other buses. And then if you have these electrifications of this corridor, you will help a lot in terms of exposing the populations. Also, not only the people that are waiting for the bus, but people that are working there, close to people selling things or foods, people that works on the streets. And then we could have this kind of prioritization of the implementation of some strategies that could make it more possible, because you don't need to think about all without thinking about the priorities. I think this could be considered also as some implementation. You were speaking about these diesel particle filters, but I never understood why we don't have these before for our buses. This is a question that I am always thinking about. Now that we have Rui here, I'd like to ask him why it was not implemented in our buses, for instance, the diesel particle filters.
Buses and trucks. Rui, would you like to comment on that?
May I, Claudio?
Shortly, yeah.
Okay, it is a very good question, of course. I think the main problem of the install a filter in a old vehicle, sometimes you can raise the consumption of the fuel because you are inputting a extra charge in the tile pipe. So people look, the buses owners, they are always making calculation to save fuel. So that's, I think, the main reason is the consumption of the vehicle, that you raise about 2% more or less. And regarding the electrical buses, I think the main question is also economical, because electrical bus costs the double of a normal bus. I think that's the problem to electrification and for buses.
Thank you, Dr. Rui. Claudio, would you like to comment on that?
Yes, I go right to the point. First of all, was told that is interesting to clean the street, to wash the street. This is not necessary. Since 1990, we use the receptor modeling. And for that, we need to measure and quantify the components of the dust. The dust basically is made of carbon and secondary components. The silicon, that is a tracer for the soil, is not so important. Mostly in PM2 particles, and now we are studying PM1. Basically, it's carbon and secondary components. Other things I'd like to comment is that we have to share the responsibility to understand, and not to share, but to understand how the things go. The cars and fuels are regulated by federal government. These are technological approach, but a non-technological approach has to be done. Otherwise, it's difficult to change. The mobility is in charge of the municipality. How the things run, the spatial lane for buses, or restriction of cars, or improving the public transportation. These are non-technological measures that must be done. And this very, very, is not good in São Paulo. Other things that you have to explain, I don't know yet. I try in the last slide show, but in the pandemic that we have a very, very restrictions or reduction, not restriction, but reduction of traffic. Even so, we do not see a lowering of the concentrations, mostly in particles. In all the world, this happened. We all the time say this vehicle. We have to understand a little bit more the city itself, the life of the big cities, to understand what happened in the pandemic. The traffic is extremely low, in the big restriction in a month, and the reduction in pollution is not so big as we expected for that. We have to explain that. We have to understand that. Otherwise, we try to, we continue to speaking about a thing that I cannot explain. I don't know why, but this happens in all over the world. Reduce the primary emission, CO, NO2, and so. The particles, not too much, and ozone increase. Not only the big restriction, but in the whole year. In the whole year, what we have? Home working, we have restriction in the schools and so and so. This means that the activity in the city was lowering, then the traffic is low, but the pollution didn't fall as much as we can. I don't know how to explain that.
Okay, I have two comments in the chat. I will read the first one by Professor Dewey. He wrote as follows: we now have technology to replace small combustion cities in cities like internal combustion cars, which can be replaced by electric cars, and gas boilers that can be replaced by heat pumps. That would decrease NOx, particulate emissions, of course, yes. And the question is, did the time come? Yeah, just like as I understand this, that means that, as Dr. Hui has mentioned, there has always been a problem of cost, but this is changing rapidly. First, as a consequence of production scale. The production scale is increasing rapidly and the costs associated are decreasing. And the new restrictions are demanding that you have this change, this shift to electric source-based cars. There's another comment by Dr. Kirkish. I don't know if I'm saying your name correctly, but she wrote a comment, a large comment here. I would like you to read it afterwards, but just the information that she thanks a lot the panelists, and there is the recent World Health Organization Air Quality Database 2022 also emphasizes that annual mean PM concentrations were relatively constant across megacities in the last years without much improvement in addition of the 6,700 settlements. Only 10% had annual mean levels of PM10 and PM2.5 that were within the air quality restrictions, and only 23% general guides, and only 23% had annual mean levels of NO2 within those guidance lines. And what else? PM2.5 attributable deaths per 100,000 people also varied by 10 times across the 250 most populous cities in the world. The comment continues about the impact, beyond impacts on individuals. Air pollution has cascading effects on medical systems, ecosystem health, and economies. What are the most impactful actions megacities can accelerate? What is the role of electrification of transport, urban planning, and renewable energy? That's an interesting question. And there's an additional comment in the virtual platform of this conference, of this present conference. There's also a presentation that compares the reference status of São Paulo based on a composite index with future urban emissions scenarios, as well as co-benefits estimated to be about $91.5 billion across the, I don't know what are those guidelines, 7, 3, and 13. Okay, I recommend that you read this last panel that is mentioned by Dr. Kilkish, and I think that's what. But there's a question at the end too. How can the co-benefits be better communicated? What co-benefits of zero-emission vehicles, for instance, and these related aspects which we have commented. I don't know if anybody has read those the chat, which was directed to all of us. And I think this point, there's an important point here, is on the impact of air pollution on the health costs, which is an important point in mega cities. And as mentioned, there's a cascading effect on medical systems, ecosystem, health, and economies, of course. And this is known, a known fact. I don't know if it has been quantified in the case of São Paulo, for instance. I don't know if Vital has any information on that.
And Roberto,
Yeah.
there are some studies from, I think it's the Health and Citizenship Institute, and the team of Paulo Saldiva from the medical school of University of São Paulo, and a few other studies like this, that estimates on 4 or even more 4,000 deaths a year caused by air pollution only in the city of São Paulo. And if we assume that for each death there are hundreds of people that get ill, and parts of them hospitalized or are needing treatment, so the costs are huge on social and also on based on workforce that is lost, and on healthcare and recovery and social costs for the public system. So it's very important to consider this when we have this discussion about how much cost to adopt some improvements on pollution control. And I want to emphasize two things that I think it's remarkable on this matter. One is that São Paulo City approved, I believe it was in 2008, a local municipal law saying that we need to change the diesel motors on the buses for electric in 10 years. This was an amazing proposal. We can discuss if it was realistic or not, but it starts a movement. Probably it could have the power of creating momentum, like creating market and demand, and pushing technology. 10 years after the approval of this law in 2018, São Paulo had less electric buses than when they approved the law. So the effect was on the contrary, and the diesel buses is clearly a major source of air pollution because it's central, it's concentrated and close to people. So this shows how lobbies, interests on the transport business could block a public policy. And also another example was the program that we had in São Paulo to I don't know the name, is how to evaluate the performance of each car every year. And this was implemented and worked for a few years, and then it was finished because people don't like this program. So the point here is how the population is informed about their interests. We are talking about health, we are talking about their health. And people voted against this and elected all the candidates for mayor of São Paulo have in his platform to banish this program because people want. So I think the lesson is we need to better communicate the problem and the priorities, and have a more broad approach by considering economic and technological and market issues to improve this process, not just to have a punctual intervention.
Yes, I think that in this case, a specific case which you mentioned, Vital, of the control of emissions, the periodic control of emissions, which was abandoned. There was one big problem related to that, is that that was implemented only in the city of São Paulo, in the municipality, not in the metropolitan area. So technically, there's no big effect. If all your neighbors do not control emission, why should you have your control have any effect on the health and so on? So this was the point at the time. But of course, this needs to be, in fact, as you are right, this must be expanded. And of course, but you know, I think anybody who's involved with planning or with urban planning, or with planning of health systems, must have that the clear this following fact, that if you implement sudden and radical new restrictions, you're going to paralyze any economy in the world. So in the whole world, all these measurements have been constantly, persistently implemented, but gradually implemented in order not to cause problems, big interruptions, big disturbances in all the economic and social systems. So you must, the art is to work with both, with the compromise, with both aspects that somehow work one against the other. But the art of the administrator is to conduct both sides, or all the sides of the problem, in order to improve the system. I think this is must be carefully done, but must be done, as you said. I agree with you. Okay, and we have, I think, Professor Andrade was, I think your hand is already tired of being raised. Please, Professor Andrade.
Okay, well, it's not just related to this question of emissions, but now I'm going to first to discuss this concerning the population and the awareness of the population related to air pollution. We had some years ago a study asking people about the questions that they are concerned in São Paulo, and not only people living in the more affordable part of the city, but also in the periphery. And the pollution is a concern. And they have the people that answered the questionnaire said that pollution, and related the pollution to the emissions, to the buses and all this. And I think in the city, I don't know if in all the country, but people are aware of the problems that the pollution brings. What I think is that maybe they are not the people that decide the political issues, and also this that say that population, that the platform of the candidates for some positions, they put to take out the measurements of the emissions is a point that was important for the voters. I don't think so. I think it was more a question of influence from a specific part of the population, but not the population, because the population knows that the air pollution is an issue. And now, all the winter time, we have these reports about the effects of the pollution, and the population appears saying that the pollution is a problem. I don't think that they don't know that is a problem. Maybe sometimes they can took first the economical, the more emergence case of the economic situation at that point, but I don't think it was that the population don't know that they must be worried about the pollution. because it affects the children, affects the elderly. I think each year it appears that the meteorological conditions and the air pollution is important, and they are very important for the health. Another thing that has nothing to do with this is about this, during the COVID, the pandemic, and then we have this reduction of the emissions. When we saw that Google data from the amount of the cars and the trucks, we had a reduction in the cars on the streets, but not on the buses. It was very small for the buses. We can see there the data. And also this, the increase and decrease of pollution, like the increase of ozone and the decrease of particles, here they were observed in all the world, but for ozone, it's not all that the stations present an increase in the concentration, even for São Paulo. When we looked some specific stations that are not in the central part, we had not an increase. It's very specific. I agree with Claudio that it's not easy. We don't know exactly all the mechanism of the formation of ozone and the impact of the contributions from what comes from outside the city to the formation of ozone, because we have to learn, because it was not possible to represent the amount of variation of the ozone concentrations, for instance, due to the COVID lockdown. And some papers, we have many papers, but some papers they made an average of the concentration of all the stations. But when we look to the stations that are more outside the city and or in the middle of the city, we see differences that's not easy to explain. Then I think we had a lot to learn about the formation of ozone. I agree with Claudio.
Thank you, Professor Andrade. Dr. Abrantes, please, you were.
Okay, I have two comments. Trying to answer the first question of Ms. Kilks. What are the most impactful actions in megacities? In my opinion, I think the short-term policy, public policy that it could be done would to incentive the buses using biomethane. I think it's a more impactful in short term and the low cost to be adopted. And the linking with the committee of Mr. Vital regarding the lobby of the buses company owners. As you know, in São Paulo, buses can have in the maximum 10 years working, and after that they are sold to the other cities. So I think if you could improve the infrastructure of the biomethane around São Paulo and other cities, we could improve the use of gas buses, and these gas buses can be sold to the other cities after 10 years. And my last comment, the guy who stopped the program Controlar is running for our state government its elections.
Okay, let me just make another comment. I think on the topic that Professor Andrade has mentioned at her introduction, we have in São Paulo something which is typical of other cities too. Cities like Los Angeles, cities in Europe now, you have many news appearing every day about wildfires. So wildfires are extreme events. It's a typical phenomenon when you have dry summer, like in US, in the west of the US, and in Europe, especially in South Europe. And here in Brazil, we have something similar when you're in winter now, in these months, when you have very dry weather. And we had, as Professor Guardani mentioned, in 2020, it was a especially intense event of wildfires. And we even measured here with remote sensing systems in São Paulo, the transport of plumes of those fires to the city, which affected the air quality. In 2020, it was a year of pandemic, and particulate matter may also have been affected by that. But anyway, I think that this is a phenomenon that affects cities in Europe, like in Spain, like in Portugal, in Greece, presently, and in the United States too, presently too, in the West. But these are, let's say, there is no technological aspect involved. In fact, there is no difficulty in terms of technology to control these extreme events. In principle, the humanity has the means to control it, to control all these wildfires, to avoid that they reach such big dimensions. The problem is that with climate change, these extreme events have been gradually more frequently, and there is the tendency, although every plan from oil companies, for instance, energy companies, indicate direction of carbon capture and storage, or reusing, or changing, shifting from some kinds of fuels to others, to cleaner ones. This is a long-term or mid-term plan, because the present situation indicates an opposite direction. So there's an expansion in the production of oil and the natural gas worldwide. Yeah? So this is more related to climate change, the increasing frequency of these extreme events, which is happening now, and I think that in short term this is going to go in the same way. I don't know if anybody has an additional comment on that, but and this is very much related with health too, of course. Is there any comment? I think everybody agrees that climate change is changing climate, and yeah, okay. We are directing much of our discussion to this, have directed much of our discussion to the São Paulo area. Yeah? For, as I said in the beginning, for two main reasons. Okay, for at least for one main reason, that São Paulo is a typical example of a mega city, and the problems that we have mentioned here, they are exactly or very, very similar in other big cities around the world, other huge urban clusters around the world. So I think that in the case of Brazil, for instance, or in Latin America, since this is a Latin American conference, in terms of Latin America, São Paulo is by far the biggest problem due to the dimension of the problems, the high concentration of people, and at the same time is the leading region in terms of technology, in terms of concern, in terms of legislations. So all this I mean compared with other Latin American countries and compared with other Brazilian cities in the region here, Latin America. So São Paulo is the leading, let's say, problem, or one of the leading problems. Of course, you can have Mexico, you have Santiago, which are in similar situations. And here, if you think in terms of technology or structure to deal with the problem, we are the leaders here too, and we are the leading region in this term. So our hopes are that all these efforts, all this accumulated knowledge, all what has been done here and partly exposed in our discussion here, has an effect in improving public health, improving life quality in the next decades. So I hope that when we have our next SDEWES conference in São Paulo, we can have a new panel like this one, and with better news like compared to the ones we have today. So I don't know if anybody else has something else to comment. I'm saying that because we are reaching the end of our panel on air quality, and if there is no other comment, no other question, I think not. There is nothing mentioned, nothing written. I would like to thank everybody. I would like to thank the audience for supporting us, for the interest. It's of course a discussion of big interest. I would like to thank all the participants here who collaborated, promptly collaborated to our event, Professor Andrade, Mr. Vital Ribeiro, Mr. Claudio Alonso, and Dr. Rui Abrantes. Thank you very much for your contribution, and I wish you good results in your studies, in your work. I thank the organization of the conference, Marco, especially Marco Ban, Professor Rita Alves, also thank you, and everybody who has collaborated to this event. And thank you for having me and for your patience and having me as a moderator here. Thank you.
It was my pleasure. Thank you.
Thank you.
Thank you, Professor Guardani. Thank you for all panelists. It was very, very interesting panel. Thank you very much.
Okay. Thank you.
Thank you.
And bye-bye.
Thank you. Bye.
Have a
Bye-bye.
nice
Thank
day,
you.
everybody.
Thank you for the attention. Thank you.